So for your warm-up here, what I want you to do is create a chart in your notes, and we're going to fill it in with the important angles in each quadrant in both degrees and radians. What I found with teaching with this is it's helpful to have a reference chart of all of these values. And specifically what I mean by that, in quadrant 1, your first important angle is 30. In radians, here we go, that would be pi over 6. So those are my two important ones for that one. You also have a 45-degree angle, which would be pi over 4, or a 60-degree angle, which would be pi over 3. So I want the equivalent values for each one. And then I want you to go ahead and do it for each quadrant. So what is a 30-degree reference in quadrant 2, both in degrees and radians, quadrant 3, quadrant 4? Because having this reference sheet will help you out a lot as we move forward. You are welcome to just pause this video and give yourself a chance to do that, or just keep playing it and I'll talk about it here. So in quadrant 2, for all of these, you're doing 180 minus that reference angle, or pi minus your reference. And how you would get that, so 180 minus 30 is 150. In radians, it's 5 pi over 6, because you get a common denominator with that pi, which would be 6 pi over 6. For your 45, 180 minus 45 is 135, or, oopsies, this would give you 3 pi over 4. And then 180 minus 60 is 120. In degrees, in radians, it is 2 pi over 3. In quadrant 3, it's just 180 plus that reference, or pi plus that reference. So 180 plus 30 is 210 degrees. If I do pi plus pi over 6, I get 7 pi over 6 because you get a common denominator. For 45, 180 plus 45 is 225. And pi plus pi over 4 is 5 pi over 4. For 60, 180 plus 60 is 240. And then pi over 3 plus that pi is going to be 4 pi over 3. For quadrant 4, you do 360 minus your reference, or 2 pi minus that reference to get this angle. So 360 minus 30 is 330 degrees. When you do 2 pi, or 12 pi over 6, minus pi over 6, you get 11 pi over 6. For quadrant 4, 360 minus 45 is 315. And 8 pi over 4 minus pi over 4 is 7 pi over 4. And then last but not least, 360 minus 60 gives you 300. And 6 pi over 3 minus pi over 3 gives you 5 pi over 3. You did already have charts similar to this in your notes, but I feel putting it together is very helpful for this next section that we're going to do, because you're going to have to be able to identify or really pick out numbers that are in this chart to help you solve the next problems that we're going to do. Today we're talking about 7.3 in your textbooks, which is your sum and difference identities. These are ones where we are going to be able to find maybe sine, cosine, or tangent of angles that aren't values on this chart. So you're going to be able to find maybe the sine of a 15-degree angle using numbers in this chart to be able to actually evaluate it. These does give you technically 6 new identities, and so you will need some time to write these down and make sure that you have these. Feel free to pause the video so you have time to do that. One note to give you here, again, once you've written it down, the plus minus signs do matter. And what they're saying, if it is a plus right here, you will use the top sign over here, so you'll also use plus. If it's a minus, you would use the minus. So on cosine, it's important that this one's right side up, the plus or minus, and this one's upside down, because if I use plus, I'm going to use minus in my formula. And if I use minus over here, I'm going to use plus in the formula. So those are important. And then same thing down here with tangent. The plus or minus has to be in the same direction on top and the opposite on bottom, because again, if you use plus here, you will use plus and then minus. If you use minus over here on the left, you will use minus and then plus. So the order does matter there. The next three identities are just the reciprocals. So I really don't think of them as additional identities, but I have written them out for you as well. What you'll notice with each of them, I wrote the identity, then I wrote it as the reciprocal function, and then I really just plugged in like the sine sum identity in, the cosine sum identity in. Take time to write those down, and then really what we're going to do is just go through a variety of examples here to really make sure you know how to do these. So what most of these will look like is something like this, where I'm going to give you, or I'm going to ask you for sine, cosine, tangent, cosecant, whichever one it is, of some angle that is not in that chart on that original page. However, what you should be able to do is either add or subtract two numbers from this original page right here. Two of these numbers should add or subtract to whatever the number there is. So in this case, 165 is the number that shows up. I need to find two of these that add or subtract to 165, and there's always going to be multiple ways to do it. Your job is to just find one that works. So for example, the first one I noticed that works is 30 and 135, but you are welcome to do it however you want. You could also do 120 and 45. You could subtract if you want to and use some bigger numbers minus some smaller numbers. It doesn't matter as long as you get two numbers that add or subtract to give you this value. You can use it either way. So if I use the first one I mentioned and I do cosine of 135 plus 30, I always start just by rewriting it. This tells me then a couple things. First off, I'm going to use my cosine identity. So I'm going to just write out the whole cosine identity. That tells you it's cosine of your first number times cosine of your second number, minus, because this was plus, sine of that first value times sine of that second value. And what I've done by splitting this apart is I've really just identified what my alpha and my beta are. So I can go ahead and plug the 135 and I can plug the 30 in each of the spots that it shows up. Oopsies, that should be a sign. What you have done is taken it from a problem that you can't evaluate in your head up until this point and broken it down into 4 exact values that we have been doing since the first chapter of this year. Now we can go through and actually evaluate all 4 of these to be able to simplify this problem. So, just as a little refresher, the 135 is a 45-degree reference. Oopsies, 2. Cosine of 135 would be adjacent over hypotenuse, so 1 over root 2. You can rationalize it or not. At this point, I'm not picky. You do have to think about quadrant. This is in quadrant 2. I'll mark this other one. It's in quadrant 1. So in quadrant 2, cosine is negative, so that needs to be a negative. And then I'm going to go to each of the next ones. For 30, I do need my other triangle. Cosine of 30 is going to be root 3 over 2. It is in quadrant 1, so it's positive. And then we go to the next one. So sine of 135 is opposite over hypotenuse. Again, you can rationalize it or not at that point. You will have to do it in the end, but I don't care here. Quadrant 2, sine is positive, so I can keep that sine positive there. And then for sine of 30, opposite over hypotenuse, so this is 1 over 2. It's in quadrant 1, and so that's my answer. From here, it's really just a bunch of algebra. So I'm going to start by doing my multiplication of each piece. So this first fraction becomes negative root 3 over 2 root 2 minus 1 over 2 root 2. What I notice is I already have a common denominator, which is great. So I'm just going to put these together. So this is negative 3 minus 1, or sorry, negative root 3 minus 1 over 2 root 2. You are required to rationalize before you're done. So if you opted not to earlier, now is the time that I would. To rationalize this, I have a monomial in the denominator. So I'm going to multiply by that radicand. I'm going to multiply by the square root of 2 on top and bottom. On top, you have to distribute it, so it'll be negative square root of 6 minus the square root of 2. All over, this becomes 2 root 4, or just 2 times 2, which is 4. As an algebra reminder, you cannot simplify this. You can't put these together because the radicands are different. You can't simplify because the top is in radicals and the bottom isn't. And so this is your final answer. What you're going to find is your answers typically look something like that. Okay, but we're going to go through multiple ways. Here I'm going to talk about one you can do with when I give it to you in radians and how I would work through that. So you do have to start by figuring out what adds or subtracts to 7 pi over 12 that is in your chart. And what I found to be the easiest way is to just start by thinking of ways to add to 7. Okay, and don't overthink this. This is where you can do like 1 plus 6. You can do 2 plus 5. You can do 3 plus 4, and so on. But you will just get with this one the same combinations. As you're doing that, what you want to check, since these all are all over 12, is put them over 12. And the requirement for one to work is that both fractions can simplify, because if these simplify, they will turn into something on that chart that we made in the beginning. With this one, for example, 6 pi over 12 simplifies, but 1 pi over 12 doesn't, so we cannot use that. With this next one, if I put them both over 12, the kind of reverse happens. 2 pi over 12 simplifies, but 5 pi over 12 does not, so we can't use this. However, over here, 3 pi over 12 simplifies to 1 over 4, and 4 over 12 simplifies to 1 over 3. These do just have pi's with them, and both pi over 4 and pi over 3 are on my chart, and that is what I'm going to use then. So again, you want to find ways to add to that top number, whatever your numerator is, but you want them to simplify. Both have to simplify with 12, and that will automatically get you some numbers from your chart. I do find it helpful to label what these are. So quadrant pi over 4 is a 45-degree reference in quadrant 1. Pi over 3 is a 60-degree reference, also in quadrant 1. And now we can go ahead and apply our identity. This tangent identity tells you to start by doing tangent of pi over 4 plus tangent of pi over 3, and in the denominator to do 1 minus tangent of pi over 4 times tangent of pi over 3. And just as a pointer before I keep going, remember, you can pick different numbers here depending upon what you found. You could have forced this to be subtraction, whatever it is. So this is not the sole way to make it work, but it is the, like, to get the correct answer, you'll get the same answer no matter what, as long as you find a pair that works. Okay, to keep going then, the next thing is to find to actually evaluate these. So I need my 45, 45, 90 triangle. And I also have a 60-degree reference. For tangent of pi over 4, that is going to be 1 over 1, or just 1. And the nice thing here, I can fill that in 2 spots. For pi over 3, again, that's a 60-degree reference. Opposite over adjacent gives you square root of 3. It is quadrant 1, so it is still positive. And then I'm going to do that multiplication and make my problem look a little simpler. On the bottom, it just is 1 times root 3, so root 3. You do have to rationalize this. Since this is a binomial, you are going to multiply by the conjugate, which, if you remember, your conjugate is you take whatever this is and you flip that middle sign. So it's going to be 1 plus root 3 on top and bottom. And then you're going to FOIL this out. So I'll write it all the way out for you. 1 times 1 is 1. 1 times root 3 is root 3. And then you have another root 3 times 1, which is another root 3. And then root 3 times root 3, which is just 3. On bottom, 1 times 1 is 1. 1 times root 3 is root 3. Negative root 3 times 1 is a negative root 3. And the negative root 3 times root 3 gives you minus 3. What's super important with these conjugates, this middle term should cancel, which is what gets rid of your radical in the denominator. And so do make sure that that happens, otherwise you probably multiplied by the wrong thing. To then go ahead and simplify this a little bit. Let's see what color I'm on. 1 plus 3 gives me 4, plus 2 root 3s, you can put those together, all over 1 minus 3 is negative 2. Doing this division, 4 divided by negative 2 is negative 2. 2 root 3 divided by negative 2 is negative root 3. And this is your final answer. Okay, we're going to try this other one too. Feel free to go ahead and pause this if you feel ready to quiz yourself, or if you just want to hear me explain it, that is fine also as well. Here we're going to have to subtract because I have a negative value there. You can choose to do it a couple different ways. You can do like a small number minus a bigger number. You can have just negative numbers all around and think about that with your quadrants. I'm going to choose to do a big number minus a small number, or sorry, a small number minus a big number. So for example, if we think 1 minus 6, well, that's not going to work because the 1 doesn't simplify. If I do 2 minus 7, the 2 simplifies, but the 7 does not. If I do 3 minus 8, these both do simplify. 3 over 12 gives me 1 over 4, which is really just going to be pi over 4. 8 over 12, 4 goes into both of those, so it's 2 pi over 3. So that's going to be my pair that I use. Pi over 4 is in quadrant 1, and so that's going to be good there. I don't have to think of this as negative 2 pi over 3 because I'm just going to use my subtraction formula, my difference formula. So I'm just looking at this as 2 pi over 3, which is in quadrant 2. When I go ahead and fill this in, your sign identity tells you to do sine of your first number, so sine of pi over 4, times the cosine of your second value, so 2 pi over 3. The signs should match, so since this was subtracted, it's also going to be subtracted over here. And then you do cosine of your first one times sine of your second one. This is 2 pi over 3. I almost wrote it wrong. And then we're going to go ahead and evaluate. So again, if it helps you, draw your triangles. For sine of pi over 4, it's in quadrant 1, so it's positive, and it is 1 over root 2. Just like before, you can rationalize or not at this point. Oopsies, I put my 60 in the wrong spot. For cosine of 2 pi over 3, that is a 60-degree reference. Cosine is adjacent over hypotenuse, so it's 1 over 2. It is in quadrant 2, so that should be negative. And then for cosine of pi over 4, it's also 1 over root 2. It's quadrant 1, so I don't change the sign. I keep it positive there. And then sine of 2 pi over 3 gives me root 3 over 2. It's in quadrant 2, so it's positive. And then I need to do all my multiplication. This first part becomes negative 1 over 2 root 2. And the second part is the square root of 3 over 2 root 2. Again, I already have a common denominator, so I'm just going to put them together. And then I need to rationalize, which since it's a monomial, I'm just going to multiply by that root 2. My answer is negative square root of 2 minus the square root of 6 all over 4. One last one to make sure we try a reciprocal function, because these can be a little more algebraically complex. Again, you are welcome to go ahead and give it a try or just directly listen to me talk about it now. So here to get to 15, 15 is smaller than any of the numbers on the chart, so I'm going to have to subtract. To me, what I always think of first is just doing 45, oopsies, minus 30, but that is not the only option. You can do this multiple different ways. If I'm doing secant, it is important to realize that that is really just 1 over cosine. And so I'm going to fill all of this in. And I start by just treating it like a cosine function, but all just under a 1. So I'm going to do the cosine of 45 times the cosine of 30. That's a minus, so this is going to be a plus in the formula because your cosine is switched. Plus the sine of 45 times the sine of 30. And then again, now we take that step to actually evaluate those. Cosine of 45 is 1 over root 2. It's positive. All these are in quadrant 1, so all of them are going to be positive. Cosine of 30 is going to be root 3 over 2. Plus the sine of 45 is 1 over root 2. And the sine of 30 is 1 over 2. I'm going to do that multiplication again right now. I really just ignore that this is in the denominator. This is going to be root 3 over 2 root 2 plus 1 over 2 root 2. And what I realize, now I start to look at the whole thing. I have two issues right here. I have a complex fraction and I have radicals in the denominator. And I would always deal with your complex fraction first. In the numerator, this 1 is really over a 1. And in the denominator, what I'm trying to get rid of is this 2 root 2. So I'm going to multiply my big fraction by that LCD, which here is just 2 root 2. On top, you're going to get 2 root 2. On bottom, both denominators cancel, and you get just root 3 plus 1. Once you've done that, it becomes a little more obvious what you have to do next. We have to rationalize this denominator, which is a binomial. So we're going to multiply by the conjugate of root 3 minus 1. On top, you're going to have 2 root 6 minus 2 root 2. On bottom, when you do all of that multiplication, you end up with 3 minus 1, or just 2. What will happen is that all 3 of these 2's are going to cancel out, and your answer is just the square root of 6 minus the square root of 2. So this is going to be the primary focus of what we're doing here, but I'm also going to give you some where I give you some exact values and you're going to have to evaluate it. So take a second and write that down and then play it when you're ready. So what I'm going to do first is just expand this identity so we really see kind of what we're working it with. Doing sine, you're going to do sine of x times the cosine of y, minus, because that sign matches, cosine of x sine of y. And we're going to try to plug in what we can. So first off, they gave me sine of x, so I can plug that in right there. They also gave me sine of y, so I'm going to go over to the other side and plug in the 1/4. But we need to be able to find cosine of y and cosine of x. And they have a few pieces of information here to be able to do that. So last chapter, first off, I forced you to use your identities to be able to solve for other trig functions. But this chapter, I'm not going to make you do that. This chapter, you are allowed to do what we did earlier in the year, which is treat this like a triangle and solve it using the Pythagorean theorem. So here, if I fill in, I always draw a triangle and label it with the x. If I fill in the 4 over 9, 4 would go, opposite, the 9 would be here. And then you can use the Pythagorean theorem to solve this, and for that missing side, you get a square root of 65. I'm going to do the same thing for the y triangle, and when you solve it, you get the square root of 15. How this helps us is that now we can fill in cosine. For x, we do have to keep in mind that this is in quadrant 1. So a cosine in quadrant 1 is positive, so that's not going to change anything. But the cosine of my x value is, square root of 15, square root of 65 over 9. And so I'll fill that in right there. For our y value, this is in quadrant 2. So I do know that cosine of y will be negative. And then to actually fill it in, it'll be the square root of 15 over 4. And then from here, you're just doing that multiplication. So it's going to be negative 4 root 15 over 36 minus the square root of 65 over 36. These have a common denominator, so I'm just going to put them together. And that is my final answer. Okay, this one works the exact same way. And so I'm going to take a minute to let you try it. But again, I'm going to start working it out, so just pause it if you need that time. So first off, for cosecant, that is the same as 1 over sine of x plus y. If I fill in my sign identity, it's sine of x cosine of y plus cosine of x sine of y. And now I'm going to need to be able to plug these in because the only thing I'm given directly is this cosine of x, and I need to find the other ones, but we can use our triangles to be able to do that. So again, I just draw one per. For cosine of x, this was square root of 3, this was 4, and so this missing side is the square root of 13. For tangent, opposite should be the root 6, adjacent is the 2, and that missing side is the square root of 10. I am going to pay attention to quadrants. My x is in quadrant 1, my y is in quadrant 4, and that will help dictate some of the signs as we move through this. So when I fill stuff in, sine of x is square root of 13 over 4. Cosine of y is 2 over the square root of 10. Cosine is positive in quadrant 4, so that can stay. Then cosine of x they gave me was the square root of 3 over 4. And the cosine of y is going to be the square root of 6 over square root of 10, which is going to be negative. When I go ahead and do some of this multiplication, it's going to be 2 root 13 over 4 root 10 plus, oopsie, sorry, now this is minus square root of 18 over 4 root 10. And you can approach this multiple different ways. If you want to simplify your fractions here, you can. I notice there's a few things I can simplify. You can also just go straight to clearing this complex fraction, which is typically what people will try to do by multiplying by that 4 root 10. And on top I have 4 root 10. On bottom I have 2 root 13 minus the square root of 18. Here is where it really would be beneficial to simplify your values a little bit to get some smaller numbers to simplify that radical. So for example here, this square root of 18 is really 3 root 2. And that really just shrinks my numbers for when I'm about to rationalize by multiplying by the conjugate. So again, since that is a binomial, I have to multiply by the conjugate. As a friendly reminder, this is a section that we would technically do without a calculator, so make sure you're doing this math in your head as much as you can. Or on scratch paper, it does not have to be in your head, especially as these numbers get big. But when I multiply this on top, I'm going to have 8 times the square root of 130 plus 12 times the square root of 20. At bottom, this really is where it's helpful to remember that your conjugates are forcing your difference of squares pattern. So what it will have to actually do is really do 2 root 13 squared minus 3 root 2 squared. Okay, because again, this is your difference of squares pattern. When I do that then, this ends up giving me 4 times 13 minus 9 times 2, which is 34. Then I'm looking really at all my coefficients. They're all even, so I'm going to divide a 2 out. This will be 4 times the square root of 130 minus 12 root 5. When I also simplify that, sorry, this 20 can simplify because it's 4 root 5, so this becomes 24 root 5. I should mention that. All over 17. I purposely here picked an ugly one. This is about as ugly as these can get, so please don't think this is a typical problem. But these algebra skills are going to be important for both here and in calculus in the future. So just make sure if you have any questions, feel free to touch base and let me know how I can help.